Hello friends, in this session we are going to discuss about fuels, especially liquid fuels and their fractional distillation. How can we separate all those? And finally, what are the applications of these and what is mean by knocking cetane number, octane number? All these topics we are going to discuss in this session. Before entering into this, first let us discuss about what is fuel first. What is mean by fuel? Fuel is nothing but any compound or substance which primarily made up of carbon. Carbon is the essential component of that one. And when subjected to combustion in the sense burning in the presence of air. So when subjected to combustion leads to give large amount of heat energy. So that energy can be used in the different forms. So this type of material can be considered as a fuel. The important condition is it should be made up of carbon as a major ingredient, and the second is so that when it is subjected to combustion large amount of heat energy should be released. So generated heat can be applied in the various purpose, so that is called a fuel. So basically fuels are classified into three types: liquid fuels, solid fuels, and gaseous fuels. So solid fuel, the best example is coal, coke, and all those. Wood is also comes under solid fuel. Liquid fuel, we have petrol, diesel, kerosene, and also liquefied petroleum gas. All these comes under liquid fuels. Gaseous fuels are nothing but biogas, natural gas, compressed natural gas, producer gas, water gas. All these are the examples for gaseous fuels. In this session, we are going to discuss about liquid fuels in detail. So liquid fuel, the best example is petroleum or crude oil. So in this petroleum or crude oil, what we have? So major component is carbon, around 88 to 83 to 87 percentage of carbon will be there. Hydrogen content will be 11 to 14%, and sulfur will be 0.5 to 3% sulfur content. Nitrogen will be 0.1 to 0.1%, and oxygen 2 to 3% will be there. Along with all these ingredients, a minute quantity of silicon, iron, aluminium, calcium, magnesium, nickel, such metals also associated with this petroleum or crude oil. There is a large difference between petroleum oil and petrol. Petroleum oil or crude oil is nothing but the crude product which extracted from the earth crust. So that is the combination of so many impurities and so many hydrocarbons. The hydrocarbon ranges from, so petrol or petroleum is nothing but mixture of hydrocarbons only. So all the petroleum oils are composed of mixture of hydrocarbons. In this, carbon content ranges from C1 to C30. So if C1 carbon or lower hydrocarbons when present, those are in gaseous state. So when hydrocarbon range intermediate, that is a liquid fuel. If we are increasing carbon chain length, so that it will convert it into solid fuel. So coal tar is the best example for that one. All these comes under hydrocarbons only. In this liquid fraction we are going to consider here, among all the fractions, so among all the fraction, petrol, diesel, kerosene, all these have the wide range of applications in automobile industry. So we will discuss about all these in detail. Petroleum, how can we extract the petroleum? Petroleum is extracted from the earth crust, especially near to the marine regions or ocean region, by drilling process. In this drilling process, what petroleum resources are available? So inside of earth crust, so many rock layers are present. By drilling of all these, we can extract this petroleum oil. So topmost layer, obviously lower hydrocarbon, that is natural gas will be there, and the middle layer liquid layer, and the bottom layer we will have solid coal tar lesion will be there. So by artificial motors and all those things, we can uplift this underground oil resources present near to the marine regions, and fuel extraction is possible. Then after the extraction, this crude product is not suitable for direct usage in the commercial applications. It needs so many kind of processing. The best suited method is refining. Refining is nothing but separation of all the particles and removal of impurities from the crude oil, and converting that into commercially usable material is called refining. In this refining, we have several steps. Cottrell's process, we are applying Cottrell's process. Cottrell process is nothing but, so by applying electrolytic method, so whatever water present in the fuel can be removed. As already we know, oil is insoluble in water. They are able to form emulsion. When it is in contact, water is in contact with brine solution, that is sodium chloride. So partial miscibility will be there in between oil and water. By this Cottrell's process, we are removing ionizable impurities. Sodium chloride is totally removed. When sodium chloride is eliminated, water is clearly separated from the oil, so that it is possible to remove this water content from this crude oil. And the second is about objectional impurities. Removal of objectional impurities, especially sulfur and the related compounds, by the addition of copper oxide. When copper oxide is added to the crude oil, sulfur containing compound is converted into copper sulfide, so that we can remove. Copper sulfide is water get precipitated, so that it is readily removed from that system. And next is about fractional distillation. It is the very important step in this, what separation of all the fractions, so that we can convert them into different kind of materials. Different fractions will have different kind of applications in our daily life. We will discuss about this fractional distillation. Fractional distillation is nothing but when crude oil is subjected to heating. So here cylindrical tube will be there. In this, from the bottom we are supplying the heat. As we are supplying heat from the bottom, here the heat content, our temperature content will be there, will be more. So as we are moving up, what happens, gradually temperature is decreased. So at the bottom state, high temperature will be there. As we are moving up, gradually temperature decreases. So based on their boiling point values, all the fractions get collected in different regions. So first fraction will be, first at the bottom level we will get solidified fraction, and different liquid fractions will be separated in different regions based on their melting point values. And at the topmost region, uncondensed material, that is gaseous or natural gas, can be collected at the topmost region. So this is about the fractional distillation process. It is the fractional distillating unit. The main and important purpose of fractional distillation is, whatever crude oil we have, that is made up of hydrocarbons. Hydrocarbons ranges from C1 to C30. Mixture of all hydrocarbons are there. So when we separate all these hydrocarbons into different fractions or different compartment, different components, they have their individual applications. That's the main application. That's the main purpose of this fractional distillation. As we are supplying the heat, different compartments in this distillator have different temperature regions. Based on the temperature zone, the type of fraction can be collected. So at their boiling point value, those gases or those materials get collected at different regions. This is about the fractional distillation. Let us see the schematic representation of fractional distillation process. Here we will see fractional distillation process in detail. So here, crude oil is taken from this material. When crude oil is given, it's subjected to oven. Oven is used to provide the heat. So at the bottom compartment, we have 600 degrees centigrade, and followed by 300, 200, 120, and the next is about 80 degrees, 40 degrees, and 20 degrees. This is about a fractionating column or fractional distillating column. Fractional distillating column composed of, so different compartments, different temperature zones are there. So at the bottom we can collect a residue of solid material, because large weight hydrocarbon can be collected from the bottom, and the remaining fractions can be collected from different outputs of this fractional distillator based on their boiling point value. So at the topmost region, uncondensed gases are coming out. Next region we will get ether fraction. Next, petrol will be obtained. There is a large difference between petrol and petroleum. Petrol stands for C5 to C9 hydrocarbons only, whereas crude oil or petroleum oil composed of C1 to C30 hydrocarbons. So petrol is the small fraction which lays in between C5 to C9 hydrocarbons, and the next fraction may be diesel, kerosene, and naphtha, followed by lubricating oil, and finally residual tar will be there. All these are the different fractions can be collected by using this fractional distillation by applying different temperature regions in this fractional distillator. So as we are moving up, temperature gradually decreases. At the bottom, high temperature, that's why large molecular weight fraction get collected. So when we are moving up, their their hydrocarbon range will be decreased slowly. That's why their boiling point values also decreased slowly. And finally, C1 to C4 hydrocarbons, which are uncondensed, always exist in gaseous state, that will be collected at the topmost region of this fractional distillator. Now let us see different fractions in this fractional distillator chamber. So here we have different fractions. So at the bottom we have residue, and next is about diesel fraction is there, followed by kerosene fraction is there, and the naphtha fraction is there. Naphtha 70 to 160 degrees, petrol in the range of 20 to 70 degrees, gas below 40 degrees centigrade we will get that what uncondensed gases. So when we are moving from bottom to top, what happens? We have different fractions. Let us go with one by one. So here gaseous fraction is there, where 40 degrees centigrade temperature when applied, we will get this uncondensed gases fraction. So this is the either natural gas or compressed natural gas we can use, and LPG also in this region, because LPG, so this gaseous fraction ranges from C1 to C4. So here when we are using this LPG, nothing but liquefied petroleum gas, which is composed of C3 to C4 carbons, so which is made up of propane, isopropane, butane, isobutane, all these are the materials which are present in this LPG. C3 to C4 fraction will be there. So this is about the application of uncondensed gases. And next is about petrol. It is in the range of C5 to C9 hydrocarbons. It is collected in the range of 20 to 70 degrees centigrade. And it is mainly used as automobile fuel, petrol, or gasoline. Gasoline is the commercial name of petrol. And next is about naphtha. In the range of 70 to 120 degrees centigrade, we will get this naphtha. Naphtha is the fraction 70 to 160 degrees centigrade. So this is the main reagent used in the chemical industry, especially synthetic organic chemistry. It is used as a solvent, and another pharmaceutical industry is also using this naphtha. So it is used in the laboratory. The next fraction is about kerosene. It is in the range. It is collected in the range of 160 to 250 degrees centigrade, and mostly used as a spacecrafts, aeroplanes. In that it is used as a fuel. And the next fraction is about diesel fraction. Diesel fraction ranges from C16 to C18 hydrocarbons. So this C16 to C18 hydrocarbon is collected in the range of 250 to 350 degrees centigrade. This diesel is mainly used in heavy trucks, motors, and another diesel engines. The residual tar, this residual tar is very important in the road construction. In that case, we can apply this residual tar. So these are the few applications of fractions which are collected, um, collected from this petroleum oil. That's the reason why it is very important to collect all the fractions, important to separate all the fractions, because individual fractions have their own application. That's why it is required to separate them. And next is about, we are discussing about petrol. Petrol is also called as gasoline. Gasoline is collected at 200 degrees centigrade, and the C5 to C9 hydrocarbon region is called gasoline. And the next another fraction we can say solvent naphtha. Solvent naphtha is collected at 200 to 250. So C6 to C10 hydrocarbons will be there. Kerosene oil 250 to 300. So its a calorific value is very high. That's the reason why it is applied in the aeroplanes and another spacecraft applications. Next is about gas oil. So gas oil is collected in the range of 300 to 350. so which is passed through the cooler to remove sulfur dioxide from that, and its calorific value is 11,000 kilocalories per kg. So this gas oil can be used in heavy trucks and motors. And the residual liquid, we can say it is a coal tar which is used in the construction of roads. So these are the different fractions which are collected in different temperature regions. Their boiling point ranges mentioned here, and hydrocarbon ranges mentioned here, very important to remember. LPG gas is composed of C3 to C4 hydrocarbon, C3 to C4 hydrocarbon region. Liquefied petroleum gas will be there. Natural gas composed of 80% of methane and the remaining small fraction of ethane, and remaining all the elements will be there. So all these comes under this C1 to C4 uncondensed gases. Petroleum ether is in the range of C5 to C7. So ether is used as a solvent. Gasoline, which is also called as petrol, this is in the range of C5 to C9. It is a motor fuel, automobile fuel most probably used. And the next is about naphtha. Naphtha is used as a solvent. Again, it is extracted in the range of C9 to C10 region. Then kerosene oil, which is a domestic and industrial uses, so many applications are there, and even spacecrafts we can apply this kerosene oil, C10 to C16. The most important, diesel, C16 to C18, which is the fuel in the diesel engines. Heavy oil is having different application. Even waxes, greases also made up of this heavy oil only. So this heavy oil further subjected to cracking process, that is important phenomena. So by breaking of long chains into smaller hydrocarbons, so that again we can improve the quality of petrol, that is called cracking. Heavy oil is very important starting material to synthesize that petrol. So now we are going to discuss about what is cracking and what is the importance of that cracking. Just now we discussed heavy oil is composed of C70 to C30 long chain hydrocarbons are there. That's why these are highly viscous, and we have so many implications in combustion process, and also using in automobiles, industries, and domestic purpose. That's the reason why we can make this long chain hydrocarbons into convenient material by the process called cracking. Cracking is very important because whatever fraction available in this fractional distillation is extremely low. The petrol is a one of the fraction remaining, all can be obtained along with that. So, but we have greater demand for that petrol, and that extent petrol generation may not be possible. So we are searching for another alternative methods. That's why heavy oil can be easily converted into the petrol fraction by this breaking of bonds. That process is called cracking. Let us define this cracking. Cracking is nothing but, so cracking is the process larger molecules break down into smaller ones by either by thermal or catalytic conditions. By rising temperature, we can cleave the bonds. Otherwise, by applying catalytic reagents, we can cleave those bonds. This is called cracking. The important application of cracking is we can convert heavy molecular weight materials into consumable and required material, that is a petroleum fraction, by breaking up their bonds, either applying heat or catalysts. So that process is called cracking. So thermal cracking is nothing but by rising temperature in the range of 450 to 750 degrees centigrade and a pressure of 1 to 70 atmosphere. So here pressure applied, excess amount of pressure and excess amount of temperature both are applied. That's the reason why. So heavy hydrocarbon, when we are taking decane, nothing but 10 carbons chain. So when it is applied by these thermal conditions around 450 degrees centigrade, it is converted into one 6-membered fraction, second is 4-membered fraction. So one is N-hexane, second is one butene. In this way, cleavage of bonds are possible, so that they converted into the materials which are required. So that's the reason why it is very important cracking process in this liquid fuels, because fuel availability is limited, fuel resources are limited, but by this fractional distillation, petrol available is only one of the fraction which is not in the sufficient quantity. In order to enhance its availability, we are making long chain hydrocarbons into smaller one by cleavage of their bonds. Now, let us see. second possible method, that is catalytic cracking. Catalytic cracking, in the sense, we can apply in some other catalyst in order to accelerate the rate of reaction to cleave the bonds. So either silica, alumina, zeolites, beads or pellets in the form of beads or pellets can be applied in order to cleave these bonds. So there are again fixed bed and moving bed catalytic cracking process are possible. So this is about the schematic representation of cracking process for fixed bed catalytic cracking. So initially we are taking heavy oil which ranges from C17 to C30 hydrocarbons. This heavy oil initially pumped into this preheater where we are maintaining temperature for 25 to 450. At that high temperature, all material get vaporized. Those vapors now allowed into this catalytic chamber. In this, we are taking the different fractions or different proportions of catalyst, either silica, alumina, or zeolite can be taken here. Aluminum oxide is also applied in this case. So where we are maintaining 425 to 450 degrees centigrade in this catalytic chamber. So these vapors coming from preheater entered into this catalytic chamber. So catalyst now associated with this vapors of heavy oil, so that cleavage of bonds are possible. Cracked vapors, so here only cleavage of bonds are possible in the presence of catalyst. Now whatever fragments are there, all those fragments now entered into this column, cylindrical column called fractionating column. Fractionating column again used to separate all the fractions, heavy oil and lightweight oil or middle oil, and lightweight uncondensed gases. Three fractions get collected here, and they are passing through the condenser, which is used to convert vaporized materials into liquefied materials by passing through the cooler or condenser, so that liquefaction of that middle oil part will be there, that is nothing but gasoline part get liquefied. So here we can collect gasoline in this container, which is the collecting chamber. Another dissolved gas is also present in this. In order to remove the dissolved gases, another chamber, now gasoline entered into another chamber, which is called a stabilizer. In this stabilizer, what we are doing, we are slowly allowing the material, allowing the gasoline as such without any shaking, so that uncondensed gas is coming up. So they get collected from the top region, and so ungasified gasoline is collected from this outlet. So this is about the fixed bed catalytic cracking. Fixed bed catalytic cracking, in the sense, in this catalytic chamber we are not making any physical movement of this instrument. This cylindrical chamber is not rotated, or there is no movement. So it is in fixed position, so that mixing of catalyst with vaporized heavy oil is possible, so that cleavage of bonds are possible. And now entered into fractionating column, where we can separate all the fractions. So heavy oil again, so used as a starting material in this method. Whatever middle oil or gasoline fraction generated at the top region is entered into cooler. This cooler used to convert vaporized materials. This is called condensation process, where vapor get converted into liquid state. Now it is allowed to enter into this collector, where gasoline gets settled. Now it entered into again another cylindrical chamber, which is called a stabilizer, where we can remove all the dissolved gases present in that, and the gasoline is collected finally. This is about fixed bed catalytic cracking. Either alumina, silica or zeolite can be used as a catalyst. Moving bed catalyst, moving bed, which is also called as fluid bed catalytic cracking, it is the most advantageous and advanced technique in the cracking process, because so when we are rotating the catalytic chamber, so uniform mixing between heavy oil and catalyst is possible. Greater the proportion of interaction, so that greater the amount of cracking, and greater the yield of gasoline finally. So remaining process will be same, but only the difference is we are rotating that catalytic chamber cylindrically, so that while rotation, all the intermixing is possible proportionately, so that greater the extent of cleavage, cracking, and the final product yield will be more. Now we are feeding this heavy oil from this preheater. So from this preheater, we are supplying to this catalytic regenerator and also this reactor. All are having the provision to rotate. Here air is supplied into this. When air is supplied, what happens that involved in, so here this is for the regeneration in the sense when we are continuously applying this cracking method, after some time that catalyst is deactivated. In that case we can apply air and catalyst, followed by again regeneration is possible. Regeneration of the catalyst is possible in this compartment. So this heavy oil vapors directly entered into this reactor where movement or mobility of the chamber is there. Because of this moving bed or movement of this catalytic chamber, intermixing between catalyst and heavy oil vapors are possible, so that cracking will be more. And after cleaving of all these bonds, now it entered into fraction matching column, where fractionating column is mainly used to separate heavy oil from this gasoline portion. Now gasoline portion again subjected to cooler, which used to condense all the what gaseous vapors into liquid state, and now it is entered into stabilizer. The main purpose of stabilizer to remove the gases present, dissolved gases present in that. When it is allowed as such without any agitation and shaking, so all uncondensed gases slowly removed from the topmost region, and from the bottom we can collect this gasoline. So let us discuss what are the important advantages of catalytic cracking over thermal cracking. Thermal cracking, we have to apply high temperature and pressure conditions, which is somewhat difficult to process. But in catalytic process, what happens, we can maintain optimum temperature around 450 degrees centigrade is enough, and no need to apply heavy pressure or high pressure conditions. External fuel is not necessary, since coal embedded in the catalyst supplies the heat. So simple coal is applied for this catalytic cracking process. And in the catalyst, in the presence of catalyst, rate of cracking will be more, so that yield of petrol will be higher. And the quality of petrol is also very high. If the quality is high, what happens, that gives more mileage without knocking tendency. That's why our anti-knocking property is also higher. So this is called quality petrol, because in this catalytic cracking method, whatever fraction obtained is aromatic in nature. Aromatic in the sense benzonoid structures will be there, so that controlled combustion, continuous controlled combustion is possible without any disturbance, so that anti-knocking property and octane rating will be more, the quality of petrol will be more by this catalytic cracking. Greater portion of sulfur escapes as H2S. So in this, finally, we are removing all the dissolved gases present in the gasoline part. That's why. So sulfur is the major impurity present in the fuel. So if it is combusted, that is converted into sulfur dioxide, which is the major cause of environmental pollution. By this catalytic cracking, it can be eliminated in the form of H2S, dihydrogen sulfide. So residual sulfur content after the cracking method is extremely low. That's why need not to worry about this sulfur impurity in this catalytic cracking process. Gum forming compounds are very less, so there is no such jamming in the material. Gum forming materials also very less. Specific catalyst we are applying, those are very cheaper in cost, easily available materials. That's why. So high performance will be there in this method. High boiling hydrocarbon side chain aromatics are decomposed preferentially. So side chain hydrocarbons and aromatic compounds are decomposed preferentially. So these are the major components produced in this catalytic cracking process. So this is about uh, liquid fuels, catalytic cracking, fractional distillation, and catalytic cracking. The purpose of fractional distillation is to separate all the fractions present in the crude oil. Crude oil is just extracted from underground of the earth, so that is not suitable for commercial applications. That's why we have to separate all the fractions according to, their boiling point values. That separation is possible. So that separation is possible based on the temperature region. So fractional distillation used to collect different fractions. So lightweight gases C1 to C4 fraction is called uncondensed gases, which have prime applications in our domestic purpose and also industrial purpose. And second is about Nafta, petroleum ether, that is also important solvent in the pharmaceutical industry and chemical industry. Next is about petrol fraction, which is the important motor fuel. which is also called as gasoline. And the next is about naphtha. Naphtha is also important um, chemical solvent. And next fraction is about kerosene. Kerosene followed by diesel. Diesel is also applied in the automobile industry. So that also plays the major role in the combustion process, and to run the vehicles, automobile industry, it is used as a fuel. And next is about coal tar, that is another heavy fraction. Those heavy fractions, heavy oil fractions are used in the greases, waxes, candles, and also road construction. In that purpose, we can apply this. That is about fractional distillation. After fractional distillation, we have the process called cracking. Cracking is nothing but breaking of long chain hydrocarbons into gasoline part or gasoline portion in order to increase the quantity of gasoline, because it have greater demand in automobile industry. That extent the production may not be possible. So based on that, what the demand of that gasoline portion, we have the special method called cracking. Cracking can be applied either by rising temperature or applying the catalyst. Catalytic cracking is more advantageous compared to thermal cracking, because catalytic cracking giving high quality petrol with aromatic rings and side chains, and also high performance of petrol will be there with a low knocking rate. So this is about liquid fuels. Thank you. Thank you very much.